yesterday we quickly took a few notes, guys, on exponential functions. Okay. Yesterday, did we get to the part where we talked about each part of the equation? About what A is, what B is, and what X is? Okay. So quickly, if you guys have not done so, I want y'all to fill that in. A, guys, that is our constant. Okay? That is our constant. It's also the number that we start with. Sometimes. Okay? All right. B, that's our base number. You guys know anytime that we have a value with an exponent, that is considered to be your base number. And then obviously the x in the equation, that's the exponent. Okay? We talked yesterday that when you hear exponential or exponentially, that means very quickly or rapidly. Okay? So as we're talking about these functions, they're either going to grow quickly, okay, or they're going to decay very quickly. Now, we talked about what the asymptote was yesterday. Did I give you guys an example of an asymptote yesterday? Yes. Okay, good. Now, do not forget, guys, our range. Listen, our range is based off of what our asymptote is. Okay? So when we're dealing with exponential functions or exponential equations, okay, our asymptote and the range are going to be very similar. The range is based off of what our asymptote is. Okay? Now, we're going to look at just a couple things, and this is what I want for you to highlight. This is what we are about to do. The first thing we are going to do is classify growth or decay. We're just going to classify based off of our base number, if it's a growth or a decay. That was in our notes from yesterday. We are going to create a table of values and graph them. So we're basically going to create a function table, and then we're going to graph those values. And we are going to identify key characteristics of exponential functions. Now, take out your text box. These are key characteristics of exponential functions. And then simply, all of these right here that we just highlighted, those are key characteristics of exponential functions. And then we're going to take just a few notes in just a second. And those notes are going to come right over here of what each of those are. All right, so right over here, guys, the domain, the range, the y-intercept, asymptote, each of those are considered to be key characteristics of exponential functions, okay? So one, we're going to classify growth or decay. We're going to create a table of values, and we're going to graph them. So like we've mentioned and like we always know, guys, we're going to hand draw these for the first one. So we're going to have my x function table, y. Those are going to be my values there, okay? And then we'll come back and we will identify key characteristics here. Okay, so the numbers for the x that we are going to use, we can use any of them because it can be all real numbers, but for graphing purposes, we are going to use -2, -1, 0, 1, and 2. Now, once you substituted each of these x values into the equation, you should have gotten 1/4, 1/2, 1, 2, and 4. Okay? So we determined that it was a growth because b, which is my base number, was greater than 1. We created a table and values, and now we're going to graph them. Okay? So simply here, get your drawing tool, and we're going to graph each of these. So the first one, we're going to go over to -2 on my x, and we're going to go up 1/4. Now notice and know that 1/4 is not going to be all the way up on that line. So we're going to place it less than halfway in between that line. Okay, because 1/4 is less than 1/2. Now we're going to graph the next one. We're going to go over to -1 and we're going to go up to a half or about halfway, as close as we can get. Okay, then we're going to go to 0, 1. So 0 to 1, and I'm just going to make that dot a little bigger because my y-axis is kind of thick. Okay, then we're going to go to 1 and go up 2 and plot that coordinate, and then we're going to go to 2, 4. So 1, 2, 1, 2, 3, 4. Okay, now I'm going to change the thickness of my line and then connect those with what I have right there. It's as close as we can get. Now, a couple things that we want to look at. One, we should already know what my domain is. What is my domain? It's your x values, and what values can we use for x? All what? All real numbers. Okay. My y-intercept is where it crosses the y-axis. And where did it cross the y-axis at? What coordinate? 0, 1. Okay? Now, something I'm going to let you guys in on a little secret. Whenever your x is 0 in your table, that will always be your y-intercept. Because how many do you have to go over to get in line with your y-axis? 0. So whatever your 0 value is for x, that will always be the coordinate for your y-intercept. Okay? All right, now the next one. We're going to talk about the asymptote and the range. So looking at the graph, guys, even if I zoom in, another one, what value is this graph getting really close to? It's getting really close to 0, okay? I want y'all to put in to the graph, or excuse me, into the equation, -3. Substitute in -3 real quick, m for x. So 2 raised to the -3, that's going to give you what? 1/8. Okay, y'all do 4 real quick. 1/16. Y'all do 10. Does it give you a decimal? Yeah, it's going to give you a big decimal, but it's going to be 0. And it gives you a whole bunch, right? Now, all of those values are still just a little bit bigger than what? A little bit bigger than 0. So when we start talking about our asymptote, y is going to be 0. It's going to get real close to this line. But regardless of what number that you use to substitute in for x, it will never cross that right there. Now, my range, we said it is based off of what my asymptote is. What can you say about your numbers? If you're looking here, all the numbers that we graph, what can you say about them? They're all low numbers. What else? They're all multiplied by 2. But the numbers on the graph, they are all larger than, if we go back to our notes, my asymptote, like we had right here, it gets close to but never touches. Okay, the range numbers that are greater than your asymptote. Okay, so all of these numbers are greater than what? What are they all greater than? Every single one of them. 0. So whatever your asymptote is, excuse me, that says equal, should be greater than, okay? Whatever your asymptote is, guys, all your y values will always be greater than it, okay? All right, so here on number 2, guys, we determined that it was a decay based off of my base being less than 1. 1/4 is less than 1. My domain, we know, is all real numbers. We're gonna use for this -2, -1, 0, 1, and 2. For x, those are the numbers that I just gave you. Once we substituted those in, we got 16, 4, 1, 1/4, and 16. Okay, now we're simply just going to graph them. Now the first one we're not going to be able to graph. It will not be able to fit. However, we will start with -1 and go to 4. So -1, 1, 2, 3, 4. Plot my point. Need to increase that just a little bit. Good. All right, then we're going to go 0, 1. Good. Then we have 1, 1/4. So we're going to go to 1 and 1/4. Get as close as you can. And then we're going to go to 2 and go to 16th. And again, that's about as close as we're going to be able to get. Now, go ahead and start connecting those. Okay. And let's fill in what we know about the key characteristics. We already decayed, already real numbers. Y-intercept is what? 0, 1. All right. The asymptote, again, what's it getting really close to? 0. So y is going to equal 0. And then my range, all my numbers are greater than what? All the numbers are greater than 0. Now, the first two that we looked at just happen to be 0, guys. All of your asymptotes will not be 0. Y'all understand that? Okay. So for my x values, we're going to continue to use -2, -1, 0, 1, and 2. When we substituted those into the equation, we got our answer. Make sure that you add 4 to it. We got 13, 7, 5, 4.3, and 4.1. Okay? We went ahead and put in the y-intercept, which is if my x is 0, it's always going to be that other number with it as an ordered pair. Now, let's quickly graph these. So we're going to go -2, 13. I know 13 won't fit on the graph right now because it only goes intervals of 10. So we're going to go -1 to 7. So -1, 1, 2, 3, 4, 5, 6, 7. We're going to go 0 to 5. So there's 6, 5. Okay. Then we're going to go 1 to 4.3. So 1, 1, 2, 3, 4.3. And then we're going to go 2, 4.1. And again, you guys just get as close as you can. All right. And then now we're just going to connect these. Like so. Okay? Now, looking at this, I told you guys our asymptote would not always be 0. What is my asymptote going to be here? What is the graph getting really close to but not touching? 4. And then my range, all my numbers are greater than what? They're all greater than 4.